x1. And when you produce the x2, you're going to need 2 units. You need a minimum of 120, maybe more, but you need at least 120. For this one, you're going to use the resource to produce only x2, and you're going to have at most 70. So you can use 70, but you can't use more than 70. You can use 2, 3, 4, 5, 59, 60, 69, but no more than 70. This last constraint, x1, x2 greater than 0, is called the non-negativity constraint. It is always written like that. You must never get it wrong. You don't have to have anything to formulate it. You simply write x1 and x2 greater than or equal to 0. It is like your signature on a document. The formulation is not complete without it. Good. Now it serves a purpose. Now that non-negativity constraints keep you from reporting foolishness. So if you're talking about tables and chairs, it keeps you from telling us about negative chairs. Notice it's called non-negativity. It can be 0, meaning you're producing no chair or no table, but you cannot produce negative 0.5 or negative 0.6 of a chair. You can have a fractional part because it can be a work in progress where you're not finished with it yet. So fractions are allowed, but negative numbers are not allowed. So that non-negativity constraint, make sure. So we mark you hard if you contravene it. Good, because it is a common sense that you apply there. So when you have done all of the formulation, you sign off on it. So this here on the board is called a formulated linear programming problem. So if you're asked to formulate the linear programming, it means you're being given a whole series of Word document and you're supposed to pick out of the words these things. That's what that instruction means. The objective and the constraints, the ST means subject to. The constraints that the problem that you are seeking to solve is subjected to. And you must know that when you have formulated it from the problem, you must always have that last line that is called the non-negativity constraints attached to the formulation. Nobody's going to tell you that after. So 2 things you must always have. The objective must begin with either min or max. Otherwise, we don't know what you're doing. And it must end with non-negativity attached. So if you get nothing right, try to get that right. So at least you have some marks there. Good. So now we must solve this. So you do it in a step process. So the first step is to find the coordinates to enable you to graph the inequations. The first one is x1 plus 3x2 is greater than or equal to 90. So I am going to focus on the equal to portion and forget the unequal portion. Yeah, you're allowed to do that so that you can solve for the values of x1 and x2. So you say let x1 equal 0, therefore x2 equals 30. And so your first coordinate there is 0, 30. You only have 1 point. You need another point. So what do you say? You say now, let x2 be the 0. And so x1 now equals to 90. So your second point is 90, 0. You finish with that. You finish, find the coordinates, and you go on to the next one. If somebody's not following, say to me that you're not following. So you take up your next equation now, which is 8x1 plus 2x2, and that's equal to 160. Again, you say let x1 equal 0. So you have your x2 equals 80. So your first coordinate is 0, 80. Then you go and say now, let x2 now be the 0. If that is true, x1 is now equals to 20. So your next coordinate is 20, 0, and you're finished with that one. You go to the next one, which is now 3x1 plus 2x2 equals 120. And you say, let x1 equal 0. Therefore, x2 equals 60. So your coordinate is 0, 60. Good. You go back again, and now you say, let x2 now be the culprit, that is 0. So therefore, x1 must be 40. So your next coordinate now is 40, 0. You finish with that one. And now you go on to x2 equals 70. Therefore, x1 must be equal to 0. So your coordinate is 0, 70. And so you graph that. So you have found the coordinates to now graph your lines. Everybody's following at this point? Talk briskly.
Yes, miss.
Yes,
Yes,
miss.
miss. Following.
Good. Now, so you go to step 2. So step 2 now is you graph, you label, and you shade for each equation or inequation. So now, what do you do for that? You look at your coordinates. This is x1, x2, x1, x2, x1, x2, x1, x2, x1, x2, x1, x2, x1, x2. Why did I do that? That tells me how to graph or to scale my axis. So you look at all your x1, 0, 90, 0, 20, 0, 40, 0. The most you need is 90. 90, 20, 40. 10 is a good way to scale. So you have settled that. For the x2, 30, 0, 80, 0, 60, 0, 70. The most you need is 80. 10 again is a good way to scale. So 10 to 90, 10 to 80. Simple. You go. You graph, draw your scales. Now I want to use black. You graph your scales. So you know without a doubt that when you graph, you're not going to start halfway and then you can't finish because you never graph enough. 0, 10, 20, 30, 40, 50, 60, 70, 80. 10, 20, 30, 40, 50, 60, 70, 80, 90. Good, you're in business now. So we're going to begin by graphing, and I'm going to use one color for each. When x1 is 0, x2 is 30, 90, and 0. So when x1 is 0, x2 is 30. Oopsie, where did I go? When x1 is 0, x2 is 30. What's going on? When x1 is 90, x2 is 0. Oh, I missed a 90, right? So I must go back and put my 90. The next one is 90, x2 is 0. Good. The next one is 0, x2 is 30. Yep. So that is going to be our line. So the name of this line is x1 plus 3x2 equal 90. So notice what I said. I graph, label. Now I shade. It says x1 plus 3x2 is greater than 90. So where do I need to build my house? To the left or to the right? Come, class.
You need to build it to the, you need to build to the left. It's less than 90.
Greater than, no, it says greater than 90.
Okay, greater than 90, so it's to the right.
To the right.
To the right. So it means then I don't need to the left of this line. You follow? Because I need to the right to build my house. Are we together?
Yes, miss.
Good. So you go to the next equation now, which is, need a brighter green. So it now is 8x1 plus 2x2 equal 160, 0 and 80, and 20 and 0. 0 and 80, here you go. 20 and 0, there you go. So you join your line and you label it. It is 8x1 plus 2x2 equals 160. No, we're only focused on the green line. It says I need greater than 160. So where do I need to continue building my house? To the left or to the right?
To the right.
So it means I don't need to the left, right? So I shade what I don't need. Notice I'm only focused on the green line. So down to the next equation now. 3x1 plus 2x2. So there, we're at this one now. So we're going to use a different color. We're at this one, the purple one that I just took. So we need our 0, 60 and 40, 0. 0, 60. Here you go. 0, 60 and 40, 0. Good. So purple, you're focused just on the purple. So you label that line now. That line is 3x1 plus 2x2 equals 120. Our focus is only on the purple line. It says I need greater than 120. So where do I need? To the right or to the left?
Right.
So it means just focusing on the purple line, I don't need any space to the right, to the left of the purple line. So you focus on one line at a time. Now it says x2 less than or equal to 70. And so that we're to graph now, this point, let me use a different color, blue. So now we're to graph this point. X1 is 0 and X2 is 70. So we go X1 is 0, X2 is 70, right there. But it is only 1 point. What it means is that whatever the value of x1 is, x2 must always be 70. So that is it. So this line is x2 equals 70. Now it says x2 less than or equal to 70. So where do I need? The top or the bottom of the line? To the top or to the bottom?
To the bottom.
To the bottom. So it means that I don't need the spot that is to the top of the line. So I am done. What about this now? Where it says, what about this? Where is it? It says x1 and x2 must be greater than or equal to 0. Where is it? Well, x1 is greater than 0 to the right of the x2 line, and x2 is greater than 0 to the top of the x1 line. So it confines us within the right-hand side of the quadrant. So if this is the quadrant, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. This is x2 and this is x1. x1 is greater than 0 over here, and x2 is greater than 0 up here. So we're stuck within quadrant 2, and that is why we only draw just quadrant 2 of the Cartesian plane and never the other 3, because you can only find your solution in that second quadrant. Good. So remember I said that the empty space is where we are looking to build our house. Your father or your mother give you a nice plot of land. You clear a space to build your house. So in here is your house spot, or what we call your feasible region. So that is your feasible region. If you graph, label, and shade consistently, the feasible region will present itself right in front of you. You don't need to go looking for it. If you consistently pay attention to one equation at a time, just like how we did a while ago. Now, for the feasible region, we need to look for the solution that minimize, in this case. If you were maximizing, the same thought process would be used. You find your feasible solution, your feasible region, and then now you must look to ensure that your house spot and your land is not encroaching on your neighbor's land. So your feasible region, you must identify the borders and highlight it, because otherwise your neighbor going to end up into court. So where is the border of your land, your feasible region? It is the lines that immediately enclose your space, your cleared out space. So I'm going to use the red line there. No, that is not bright enough. Let me use a different red. So I'm going to outline it. There is your border. There is your border. You followed it faithfully, otherwise your neighbor going to take you to court. So you move their land border. So the outlined area is your borders of your feasible region, or the space of your property. Now, why do we outline it? Because you need to put in your corner fence. Your corners will occur where two or more lines intersect on that border. So your focus is now on the red border. You're going to put in fence posts on the corner points. Mathematically, a corner occurs where a minimum of 2 lines intersect. So, beginning to the bottom where the 90 is, right there, a fence post, and you label it A, you're going to drop 1. Continue clockwise. See right there where the purple and the yellow line intersected is another fence post. You continue up, there is another corner, and there is another corner. So you have 4 corner points, 4 fence posts. Tell me if you're following quickly.
Yes, miss.
Is there anyone who has any problems? Speak now or forever hold your peace, or have no peace to hold. Everyone is following? Good. So what we do now is that we evaluate our corner points. Why? Because that is where we're going to find the solution to the problem. So you first identify your feasible region after your graph label shade. So what is the fourth? So your graph label shade, that's step 2. After your graph label shade, so I'm gonna write down step 3. After your graph label shade, step 3 is to identify the feasible region and outline the borders of the feasible region. So we did that. We graph label shade, then we identify the feasible region, and we outline the borders of the feasible region. Good. Step 4 is to find and label, and you use letters, not numbers, the corner points on the border of the feasible region. Step 5 is to find the coordinates of the corner points on the border of the feasible region. And when you break it down into little steps like that, you're good. The journey of 1,000 miles begin with 1 step. 1 step at a time, and you solve this. Easy peasy, breezy cover girl. So we're at the step where we must now find the coordinates of the corner points on the borders of your feasible region. So beginning with corner point A. So we're going to now find the coordinates of the corner points on the border of the feasible region. Beginning with coordinates with corner point A. What are the coordinates of corner point A? Quick o'clock. What are the coordinates of corner point A?
Near 90.
90, 0.
90.
What's the coordinates of corner point B? Are the coordinates of corner point? Huh? You're not sure because it's intersecting at a point that is not exactly at the scaling. So you put a question sign there and you move on. What about corner point C? It's the same thing. You put a question sign and you move on. What about corner point D? You can read that off Clearly? Nope, because it doesn't occur at intersections. Notice this is inside of the graph. So we put a question sign. It means we have work to do. So let's find corner point D, because that looks easier to find. How do I find it? Use simultaneous equation. No. Well, what simultaneous equation am I to use? That's where your label comes in. What is the label on the blue line? The blue line and the green line intersect to form corner point D. What are the equations of those two lines? X2 equals 70. So X2 equals 70. And what? 8x1
And 8x1 plus 2x2 equal 160.
Good. So you must solve these two equations simultaneously to find the corner point for D. What about for corner point C? It is the purple line and the green line that intersected to find corner point C. So we must use those two, the 8x1 and the 3x2. So for corner point C, we're going to solve 8x1 plus 2x2 equals 160 and 3x1 plus 2x2 equals
2x
120.
equal 120.
Good. So now we look at corner point C. What do we need to solve for corner point B rather? What do we need to solve to find the equation for corner point B? Let me make sure I have that labeled right. Right, for corner point B. What equation do we need to solve to find the coordinates for corner point B? What are the equations we need to solve? The equation
The one for the purple line and the one for that mustard.
for the yellow line.
The 3x1.
Mm-hmm.
Yes, and that, yes, miss.
And the yellow line. So we need to solve 3x1 plus 2x2 equal 120. 3x1 plus 2x2 equals 120, and the yellow line was x1 plus 3x2
equals what? X1 plus 90.
x1 plus 3x2 equals 90.
Equal 90.
Good. So corner points B, C, and D have to be solved for. We cannot guess what they are. No guessing is allowed. Why? It is a coordinate response you need to give. So if you ever give them, you go to the land management agency and you tell them that the coordinates for your land is such and such. When they drop those coordinates into the land management agency satellite system, they must see your boundaries. So if you give them coordinates that are not correct, you're either going to give away some of your land or you're going to try to be stealing your neighbor's land. And either way, well, you can give away your land if you want, but they're not going to allow you to take any of your neighbor's land. So as family members, you can't all go down there to say, this is my coordinate. And then when they put them in as many different places they get in, everybody must have the same coordinates. So it means you have to solve it and get a scientifically correct coordinate. So your task for your homework is you are going to solve the simultaneous equations that we have written on the board to get the coordinates for corner point B, corner point C, and corner point D, as in dog. And then we will pick that up from there. Now I said I'm going to run class over a few. Does anyone have to go to another class after this? Do you have a test? Am I encroaching on anybody other class other than your free time?
No, miss.
All right. Please.
Would my free time be a dental appointment?
Can you call them and tell them you're going to be a little late, or can you work on the road with your phone?
Miss, how much over are you going to be?
I need about 20 minutes because I'm simply going to show you how to tackle the other questions. I need about 20 minutes.
Yes, that's fine.
All right. Thank you. Abigail, show me back your tutorial sheet. So I'm setting you up to have the work all completed for next week so that everybody has the same basic understanding. Come, Abigail, show me back your tutorial sheet. And everyone is to be looking at
I'm sharing.
Good. Okay, I'm still sharing, am I not? All right, there you go. Go ahead now. Good. Go back up to question 6, Abigail. Straight up. Come down some more. Here am I. 7. Go to 7. 7 is what I need. There you go. Good. Now, look at the table. Take off your solution. So come down such that all you see is instruction, formulate a linear programming model. No, come down. No. So take off your solution. Right. Come. Great. Go up a little more. Right. Good. There you go. Very good. Oftentimes when you get a problem for linear programming, this is how it is going to be given to you. You will have to take it and make it look like the question we just worked. That is, you're going to have to formulate the linear programming problem. Good? So the question is, how do I make sense out of all of this information? And if you get it wrong, remember your whole problem is going to be wrong. So the formulation is of the utmost importance. Now let's read the problem. It says Megan McCoy wakes up on Tuesday morning and remembers that she promised the PTA she would bake some cake or cornmeal pudding, right? For the bake sale, must be a prep school. However, she doesn't have time to go to the store to get the ingredients and only a short time to bake things in her oven. You notice that sentence? It is setting you up right away to tell you that she has an objective to achieve, but right away she's facing the constraints. Time to go shop. Everybody have to go join line to go in the supermarket. And she only have a limited time to bake. So she's facing constraints in terms of ingredients to get and the time to actually bake. Good. It says because cakes and cornmeal puddings require different baking temperatures, she cannot bake them simultaneously. She said there's a problem is setting you up. And she only has 3 hours available to bake. So the time she's going to spend on the cake and the time she's going to spend baking the cornmeal, she will only have 3 hours to do all of that. Good. Now it says, a cake requires 3 cups of flour. It seems to have changed thought. It is telling you now about ingredients. It sets you up by telling you that she has limited time to bake. And it tells you that the time she has to bake in total is 3 hours, the limitation. And it also sets you up to tell you that she had a problem to go to the store to get the ingredients. And now it's talking about ingredients, which means it is explaining what the limitations are on the ingredients and how to share that limited resource. It says a cake requires 3 cups of flour, and a pan of pudding requires 8 cups. And so she has 20 cups of flour. So she's going to have to share the flour, the 20 cups, between the cake and the pudding in the ratio given. 3 to cake and 8 to pudding. It also swings back again to tell you about the time for baking. It says 45 minutes to bake a cake and 30 minutes to bake a pudding. But I think it should be the other way around, because I think cornmeal pudding require more baking time. But anyway, what do I know? And then it tells you about the profitability. It says when she goes to the PTA to sell, she's going to make US $10 profit off the cake and US $6 pudding. She wants to know how many pans of cakes and cornmeal she should make. But part A simply says formulate the linear programming problem. All right, so 3 hours, 3 and 8. No. All right, you can stop sharing for me, and I'm going to show you how to set up the table to solve any linear programming problem. So what I'm going to show you is a general method to help you to set up the table so that you can solve any linear programming problem. The first thing to figure out is, what is it that she's trying to get to the market? What is she trying to get to the market?
Cake.
Puddings and cake.
You must list them in the order that they said. Cakes and puddings. So she's trying to get cakes and puddings to the market. Good. Now the question after that is, what are the resources? RESOU. What are the resources that she needs to get the cake and the pudding to the market? Just tell me what they are. According to the problem, what are the resources she needs?
The time to bake them and the ingredients, Miss.
Great, she needs the time and the ingredients. Now, what are the limitations on the sourcing, on the resources that she has, LIMIT? What are the limitations on the resources? How much time she has?
You only have 3 hours available to bake, Miss.
3 hours. And how much ingredients she have, in this case, flour? What does the problem say? How much flour she has?
20 cups.
But she has 20
cups.
cups of flour, Miss.
Great. Do you see what I have done with the table?
Yes, Miss.
Good. If you follow that setup of the table, then you are home free if you make no mistakes. So, how much time does she need to bake a cake according to the problem?
45 minutes, Miss.
And how much time she needs to bake a pudding?
30 minutes.
How much ingredients in terms of flour? How many cups of flour she needs to make a cake?
3 cups of flour and 8 cups of pudding.
Good.
Wait.
So yes, 8
pudding
cups.
requires 8 cups.
Right. So we have allotted, according to the problem, all the ingredients. What is the objective she's trying to achieve? She wants to maximize profit because it tells you about she can make this amount of dollars if she sells this and this amount of dollars if she sells that. What is the profit she wants to make on a cake? or she can make, according to the problem? Come, class. What is the profit she can make when she sells a cake?
Maybe $6.
No, per cake.
$10.
$10.
And how much on a pudding? $6. There is the shell to make up to formulate your linear programming problem. If you're able to separate the information in such a manner, you're almost home free. So this is what you're going to do now. You're going to say, let X1 be the first product that you write down. So you must always write it down in the order that the problem mentions it. And you're going to let X2 be the second product or whatever product is mentioned. Then you're going to write your linear programming in terms of your products. So let me just take out this line so that it is not so long, so I can get that space. Good. So that's what it looks like. This is how you now write your linear programming. Pay careful attention. The objective, you begin with your objective. You maximize your objective such that you make $10 per cake, and is represented by a plus, and $6 per pudding. Do we see that?
Yes, miss.
Yes,
It is subject to the following constraint. Now listen, now since the time for the cakes and the puddings are given in minutes, it means you must convert this to minutes. 3 hours in terms of minutes is what? How many minutes? 6 3 is 18. It's 180 minutes.
180.
Good. So you must convert that. You have to exercise your common sense. You can't be using 2 different units. So you are subject to now, you're subject to, I want to use a different color so that it's subject to now. For each cake you make, you're gonna take 45 minutes. So for each cake, it takes 45 minutes. And for each pudding, it takes 30 minutes. And you have at most 180 minutes. Do you see that? Less than or equal to tells you that you can use less than the 3 hours, but the most you can use is 3 hours. Are we together?
Yes, miss.
Good. Go to the next one now. So we're talking about now the ingredients. For each cake that you make, it requires 3 cups of flour. And for each pudding you make, it requires 8 cups of flour. And the most cups of flour that you have is 20. You can use less than 20, but you can't use most. And you have allocated all of the ingredients or all of the constraints as the problem gave them to you. You have written in the objective as the problem indicates. So you're done with the formulation. What must I write next?
Mr. Non-negativity thing.
Right, constraint, non-negativity constraint. You must sign off now. X1 and x2 is greater than or equal to 0. Voila, you're done with the formulation of your linear programming. So if you can master the art of the table, you can master formulating any linear programming. The first step is to identify what are the products I am trying to get out to the market or to make. Then you identify what resources do I need to put into the making of those products. Then you go to what are the limitations on the resources. Of course, you keep in mind what objective it is you're trying to achieve in going through all that analysis. It is to maximize profitability. So you begin now in the formulation by stating the objective and then writing the constraints that the objectives are subject to. And when you're finished, you sign it with a nice flourish. X1, X2 greater than equal to 0. There, you're done with the formulation. Now notice that in the formulation, everything is in relation to the products that you want to get out to the market. Do you notice that? Because everything is about the products that you want to get out to the market. So tell me if anyone has any problems with what we have just done.
No, miss. But for the first one, miss, it shouldn't be equal to anything.
No. What are you saying? When you say the first one, though, equal to, you rarely come across an equal to in a linear programming, but what are you asking me about so I can address that specific question? You mean the max?
Yes, miss.
No, you don't make it to equal to. Listen to how it is read. The max is you maximize. The Z is your objective function. You follow? So you're going to maximize your objective functions. What do you call this? Colon or semicolon? Colon? The two dots. Is it colon or semicolon?
Yes, miss.
Colon. So
Colon.
the colon means such that. So that's a mathematical way to write such that. So you're going to maximize your objective function such that it is equal to. So that colon means a whole lot of words. Maximize the Z, your objective function, the colon, such that is equal to what? Equal to this expression that I just circled. Do you follow?
Yes, miss.
Yes, miss, following.
Great. So if you are able to master the art of the table, then you can master the art of formulating your linear programming. You just now have to be very careful about how you insert your inequalities. You have to make sure you get them correct, because if you get them incorrect, you're going to highlight the wrong portion of the feasible region, or what the feasible region should be. So you have to look carefully at the problem. She said she only had 3 hours to bake, which means that she can use up to 3 hours or less than 3 hours. She also only had 20 cups of flours. She can only use 20 or less than 20. Suppose it had said she need a minimum of 20 cups. It means that she could use 20 or greater than 20. So that should tell you that it should be a less than or greater than. or greater than or equal to, sorry. It should be a greater than or equal to. So you have to watch the language of how the information is presented to you. It's a delicate balance. It is writing, but no word is unnecessary. So are you following what I'm saying and what I just did? Tell me quickly.
Yes, miss, following.
Yes, miss.
So now I'm going to, did I assign the linear programming question?
No, miss.
No, miss.
No, miss.
So I am going to assign so that nobody comes next week and say they were not able to do anything. So Abigail Marshall, question 7. We started the process, so you're going to finish it. Abigail Marshall, question 7. David Gordon Rowe, question 8. Jamie Williams, question 9. Keon McDermott, question 10. Keon. Laurie Walters, question 11. Laurie. Markland, question 12. Nadelia, question 13. Nadelia. Samoya Time, question 14. Samoya. Shakila, what question does it finish? Shakila, question 15.
Finishes at
18, miss.
Shakila, question 15. Tashik Pringle, question 16. Where are the others?
Miss, I don't see a 16.
It is.
It's 14, 15, 17.
So Tashik, question 17. And Mr. Gordon Rowe, you're going to get 2 questions. So Mr. Gordon Rowe, question 18.
So, Miss.
Yeah.
Miss.
Yes, Nadelia.
Miss.
Hmm?
This is Nadelia. Which question am I assigned to? This is
13.
Nadelia.
Question 13, Nadelia.
Okay.
All right. So again, Abigail, question 7. Gordon Rowe, question 8 and 18. Jamie, question 9. Keon, question 10. Lorian, question 11. Markland, question 12. Nadelia, 13. Samoya, 14. Shakila, 15. And Tashi, question 17. So go thy way and work, and we will, next week, we will look for a time where we can do one extra class and wrap up everything.
Miss,
And you will also have your grades next week.
Miss,
you said you were going to.
Huh?
Miss, you said you were going to say something about test 2.
Oh yes, test
You were
2.
going to say something about test.
Thank you. How did you decide for the second regression problem, which was the independent and which was the dependent problem question variable from the question? How did you make that deduction? From the information presented, how did you deduce which variable should be your dependent and which should be your independent variable?
Miss, that was giving us a problem, but I don't remember if it's was it question D?
Mm-hmm.
Yes.
Information.
Okay.
Yes, Miss.
Question D, can
Information.
you give us a hint?
Okay, great. So that's what I wanted to hear. Because I asked somebody else and they were trying to say from the table. There was nothing in the run-up that will make you know that. You have to have information to help you know that. When a question like that is posed, you cannot reason it the way you feel like. You have to know what is in the mind of the person who came up with the study. Nothing was in the run-up, but you recovered yourself by looking at the questions. So What must I learn here? When I have a problem and I don't know how to think about the problem, look at what the questions are asking you and use that to help you to determine what was in the mind of the person who posed the problem. So there was nothing in the run-up to the question that told you how to think about the data. But if you went to that last question, you realize that, oh, this is how they want me to think about it. Okay? Now, what does it have to do with this topic? If you're not sure what products must go out at the X1 and X2, look at the questions and look at what they're asking you to make a decision on, and that will tell you what is to go at the product section. Are we together?
Yes, ma'am.
Good. So off you
Miss
go
question.
now.
Miss, for question 15, where does it end? It goes straight down to part F just before 17.
Yes. As a past exam
Or
paper.
somebody else who's looking at the tutorial sheet.
No, it's a past exam paper, so you should be able to manage that question. That question came from a paper from 1 year. So that question I know is a past exam question.
Right, and it goes straight down to F.
Yes, it's a pretty long one.
Because I'm not seeing question 16, so that's why I was asking me.
Yes, so we will go with the numbering.
Error.
We will go with the numbering that is on the paper to take out any doubts and questions. So just do the questions as they are on the paper. All right? And you will have your grades next week.
And this is for next week, Wednesday, right, Miss?
Yes, it is.
Okay, and then when is the makeup class?
We're going to have it maybe if we can do it Wednesday night or Thursday night or one of those. We will decide at that class. So we will see how much we get done, what we have to do, and then we decide when we will meet for that class. And I might invite other students depending on what their achievements are. But we will make that decision at that class. Okay?
Yes, Miss.
All right. So see you next week. All being well.
Bye, Miss.
Bye-bye.